Everyone. My name is Mahendra Kumar Tamrekar. We are going to dive into some fascinating aspects of computer networking, covering everything from network protocols to how data gets delivered efficiently across the internet. I will break it all down using simple analogies to make it easy to understand. Let's get started. So, first, let's talk about collision-free protocols. Think of collision-free protocols like a busy intersection with traffic lights. Just as a traffic light ensure only one direction of traffic moves at a time, these protocols ensure only one device can transmit data at a time. They are predictable, so great for real-time applications and work well in busy networks. Let's, for example, include TDMA like TV channels, each having their own frequency, polling like a teacher calling on students one by one, and token passing like a talking stake in a meeting. Here, now on the other hand, limited contention protocols are more flexible. Imagine a classroom where students raise their hands to speak, but once someone starts talking, they get to finish their point. These protocols adapt well to different situations. For examples include binary countdown, like holding up number cards with the highest number going first, adaptive tree walk, organizing people into groups to take the turns, and the flexible handling. Flexible handling is like a limited contention protocols allow for flexible handling of network access to minimize collisions and improve efficiency. And also, the one more example is reservation aloha, where successfully speaking once earns you guaranteed spot in future discussions. So let's move forward. Let's explore bit-oriented protocols, which are like different languages computers use to communicate using streams of bits, ones, and zeros. One of the big players here is SDLC, developed by IBM. Uh, it's like a traffic controller that uses a specific bit pattern, like 0 1 1 1 1 1 1 0, to signal a new message. SDLC can work in point-to-point or a multi-point node modes and has three different operational modes. Now, let's go forward on high-level data link control (SDLC). Here, SDLC is developed by ISO, which is like SDLC's more sophisticated cousin. It uses three types of frames: information frames called iframes for the main message, supervisory frames called S frames for smooth operation, and unnumbered frames, U frames, for special instructions. Another interesting protocol is LAPV, Link Access Procedure Balanced. It is part of the X.25 suite, which treats both ends of communication as equals and ensuring reliable delivery like a return receipt for every piece of mail. So let's go forward. Now, let's talk about the protocol verification. Here, protocol verification, which is like quality control for how computers communicate. We use tools like finite state machines, FSMS, and battery nets to map out protocol behaviors. FSMs are like following a recipe where you move from one step to another, or as one state to another, such as idle to sending data. Battery nets, on the other hand, are like conducting an orchestra where multiple things happen simultaneously. They are great for modeling complex systems like a busy coffee shop for drive through, where multiple orders are in different stages at once. Moving on next, here the protocol verification. Here the some of the advantages that you can see: ensures error-free processes, utilizes formal methods applicable in various industries, improves system reliability, facilitates communication between stakeholders, supports model checking, enhances system design. reduces development cost. Moving on, let's discuss some game-changing network technologies and how we measure their performance. The first one is the fast Ethernet. The fast Ethernet, it runs at 100 Mbps and works with older 10 Mbps equipments, making it perfect for office networks. Whereas Gigabit Ethernet is the speed daemon at 1000 Mbps, ideal for data centers and multimedia. FDDI, Fiber Distributed Data Interface, uses fiber optic cables and has a dual ring design, making it a great for connecting large campuses. So now the performance matrix is used is used to measure performance like bandwidth for maximum speed, throughput, the actual speed, the latency, time of data to reach its destination, and the jitter, what a variation in timing, and the packet loss error dates, how much data gets lost or corrupted. Uh, हम इसको सोच सकते हैं कि like a highway, we can think it like a highway. Bandwidth is the number of lanes, throughput is the how many cars get through, and the latency is how long the journey takes. Now let's move forward. Let's compare IPv4 versus IPv6. IPv4 is like a city with limited number of street addresses, about 4.3 billion as assumption, but we are running out. IPv6 is like a building a new city with practically unlimited addresses, enough for every grain of sand on earth. IPv6 is also faster, more efficient, and comes with built-in security features, unlike IPv4, where you need to add security separately. Here the you can know about address size. Address size of IPv4, it uses about 32 bit of address, and whereas the IPv6, it uses 128 bit of address, offering an almost infinite number of addresses. Now, finally, let's talk about mobile IP, which is like having a personal mail forwarding service. Your device is like someone who travels a lot but wants to keep getting mail from their home address. Here the home agent HA is like your post office and that known where you are, and the foreign agent FA is like a temporary post office in the city you are visiting. This system lets your phone keep it connected while you are moving around, whether you are using 4G, 5G, or switching between the Wi-Fi networks. And at the last, let's TCP header, which is like the shipping label on a package. It has several key sections, like the source and destination, ports like the from and to addresses, sequences and acknowledgement numbers, help to put data in the right order, whereas data offsets link like a table of content telling us where the actual data begins, control flags, special instructions like SYN, hey, I want to start a conservation ACS, got it, thanks, and fin, okay, I am done talking. Windows I tells the sender how many packages it can handle at once, and checksum like a tempered evidence seal to ensure nothing got damaged in transit. So it's over. Let's you here. I have to tell you about one more interesting thing about Bisin, BISYINC. Another IBM creation was like the grandfather of these protocols. While it's not fully bit oriented, it works with characters instead of pure bits. It was revolutionary for its time. It's like using Morse code in a word of text messages. It worked well, but eventually got replaced by the more efficient methods like then we have LAP and LPV that we have talked in about the protocols here in the bit control protocols, in the limited content protocols, here the bit control protocols. So that's it. Thank you.